Okay, ladies and gentlemen, this is Mr. Weideman, and I'm going to talk about some example problems that we didn't get to class this morning. These example problems are going to be really important to help you with your homework. Some are really straightforward, like this first one, although there was an error here. This is x approaches negative pi, and that's incorrect. That should read as x approaches pi from the left-hand side. Right, or the too small side, or the negative side. Also, when you're doing this, you should be using your calculators. Make sure that your calculator is in the radians mode. Okay, otherwise it's not going to come out too well. All right. So what I did here is it's just plugger and chugger. I used my calculator, and I just got closer and closer to pi. And it's quite obvious that the closer and closer I get to the value of pi in my calculator, the closer and closer I get to a value of -3. All right, so that was pretty straightforward. Now, let's take a look at this next one. All right, now the next one here, I approached it the same way. I plugged in values that got closer and closer to -4 from the left side. All right, so the first thing I tried was -4.1, and I got this value. If you notice that this was very tedious to put into your calculator, you're right. It was tedious to put into your calculator. All right, and then I tried this value. So the only thing that really changed right here still wasn't very confident, so I kind of took this to an extreme. Got really close to -4 on the left side. All right, and I can see that this is getting pretty close to 1.75. As I played with this and used even more numbers, it did get closer to 1.75. And you may be thinking to yourself, man, there's got to be an easier way to do this. And actually, there is. Okay, if we take this problem right here, and what I did is I took what we had, and I took our equation, and I factored it. Okay, so I know I can clearly see that -4 is some sort of discontinuity. It makes the denominator 0, so that is a bad point. I factored this thing, and when I did factor this thing, that x equal -4 turned out to cancel out, so that x equal -4 is a hole in the graph. And if I factor out the hole, I come to this equation. And if I take the limit of that equation, well, it's not discontinuous at -4. I can just simply plug -4 into this equation, and I get this 1.75 to kind of check my work. And that's an easier way to do it. And that kind of confirms that it did converge at 1.75. Last but not least, you can put this in your calculator and use the trace button and get closer and closer to -4 from the left side. Okay. So that one could still have been evaluated by just plugging and chugging. Okay, let's take a look at the next one. Okay, now this is asking something. Is it continuous at C? And, you know, if I plugged in 0 for x here, I can see I have 0 in the numerator, 0 in the denominator. So I have a 0 divided by 0. Is that a true discontinuity? And it turns out it is. And obviously, if the graph is not even defined at C, it's not going to be continuous at C. But let's investigate this. Is this legit? And it turns out, no, that's not right. It's not continuous at C. I can't have 0 divided by 0. All right, so it's not even defined at C, so therefore it can't even be continuous at C. Okay, now we're going to play with this equation for the next one, okay, because the next one is a piecewise function. Okay, and we know that in this function, it's not defined at 0. But this function is defined at 0. All right, so just it's defined at 0, but it's asking, is it continuous at x equals 0? Well, let's find out. Okay, so I know I'm defined, and if I go to graph this thing, what I did is I took this and I said, well, is this function is defined at 2. This function right here, it has a limit. Turns out that this has to be a hole. So if I kind of graph this thing, all right, here's that function. There's my hole that we found out in the previous problem. Okay, so it's defined at x equals 0, but it's not continuous at x equals 0 because I have to pick my pencil up and go to here. All right, so when we do this, if our calculator can be our friend, but it can also lead us in the wrong direction. All right, let's take a look at this graph. And can we see that? Kind of, sort of. Lots of glare. How about there? Nope, nope, nope. Okay. All right, there's our function graph right there. And you go, oh, it looks just fine and wonderful at x equals 0. However, if we go to our table, we see at x equals 0, without the glare. Stop it. Nope. All right, at x equals 0, all right, it's undefined. Okay? In that function, it's undefined in this function, but it is defined in this function. So it's defined at 2, but it's not continuous at 2. Okay, so what's the whole point here? The whole point is you have to kind of look at all of our different techniques. You know, some of it's just easy as plugging in and evaluating on both sides of the limit to see if it converges to some sort of number. In other ones, we have to not only look at our discontinuities, you know, what kind of discontinuities are they? And if it is defined at certain points, we need to look and see, you know, is my piecewise function continuous, which this one is not. So don't be afraid to use your calculators. Don't be afraid to factor and cancel things out. Don't be afraid to use your graphing calculator to kind of look at the big picture. Use all the tools that are available to you.